Are we actually capable of being rational decision makers? Well, we're probably capable of it, but we don't tend to do it very often. A way of measuring what is rational comes to us from something called utility theory. And this just uses a very simple formula to determine what's called the expected value of an option. The expected value is just the probability of a particular outcome times the utility of the outcome. And it's better to make sense of this in a context of a simple example. How about a lottery ticket? So what's the probability of winning the prize of this lottery ticket? Oh, 1% chance, right? And what is the prize? $200. So the probability is here, 1%, and the outcome is $200. And so we're just going to multiply 1% times $200, and that gives us $2. So how much is this lottery ticket worth? It's worth $2. If they're selling it to you for $2, you're buying it for what it's worth. If they're going to sell it to you for $10, you're paying way more than it's worth. So that's a way of measuring how rational this decision is. Now, it turns out that how a question or decision is framed ends up being really important to us because we are what we can summarize as loss averse. We don't like losing. We don't like negative outcomes. And so we will try to avoid them. And this can be used again by salespeople. You can tell someone that they need to replace or upgrade the insulation in their home, and the best motivation is going to be one that makes them scared that they're losing money. So we can look at these two options. You'll save money by replacing the insulation in your home. Very nice. I like to save money, but much more powerful is if you tell me I'm losing money every month by not replacing the insulation in my home. This is the one, the losing money is the one that, we don't like that, right? We're not going to be happy with that one. We are going to be much more motivated to choose that option to increase the insulation because we don't want to lose money. We are loss averse. Now, this loss averse that we experience has been studied in terms of to see how it affects our decision making. So here we have a problem that's going to be framed positively in the top and then negatively in the bottom. So let's just go through it. First, the positive framing with more safe wording. So imagine that the U.S. is preparing for the outbreak of an unusual disease. So go ahead and read that paragraph. Okay, so what makes this one a positively framed choice is that what's being emphasized is the number of people who are going to be saved. That's what's mentioned. So if program A is adopted, 200 people will be saved. If program B is adopted, there's a 1/3 probability that 600 people will be saved and a 2/3 probability that no people will be saved. Now, what's the difference between A and B? Program A is a sure thing. Program B has a little bit of a gamble, right? There's a 1/3 probability that all 600 people will be saved, but also a 2/3 probability that nobody will be saved. Now, in terms of the rational decision making, the expected value, these are actually the same. So, how is that the case? Well, remember with the lottery ticket, you have a 1% chance of winning $200. The expected value then was 1% of 200. That was $2. Well, here we go. We have a 1/3 probability. That 600 people will be saved. What's 1/3 times 600? That ends up being 200, right? So both these options are actually numerically the same. It's just one is a sure thing. Program A is a sure thing. Program B has the same expected value of 200 people being saved, but there's risk, and we're gambling here. So that's the only difference, but the expected value is actually the same. It's 200 in both program A and program B. Now let's look at the same problem with negative framing. So go ahead and take a moment and read this one. So notice the negative framing here, right off the top here. Oh, it's expected to kill 600 people. 2 alternative programs to combat disease have been proposed. Assume the exact scientific estimates of the consequences are as follows. Program C will lead to 400 people will die. Negative framing, right? If program D is adopted, there's a 1/3 probability that nobody will die, and a 2/3 probability that 600 people will die. So whereas positive framing emphasizes the number of lives saved, negative framing is emphasizing the number of people who will die. Now let's look at the expected value here, right? What would be the rational choice here? And once again, I think we're going to find that it's the same. So if program C is adopted, 400 people will die. Wait, isn't that the same as saying 200 will be saved? Yeah, right? It's the same as program A. If 200 people are saved, that means 400 are dying. And so program C is the sure thing that 400 people will die. Program D is going to have the same value, but it's the gamble. And the gamble is that 1/3 probability that nobody will die, and a 2/3 probability that 600 people will die. So once again, 2/3 that 600 will die. That means that 400 people are going to die. So program C, 400 people will die. Guaranteed, right? No gamble. Program D, 400 people will die, but there's this risk, right? You have probabilities. 1/3 probability that nobody's going to die, and 2/3 probability that all 600 will die. But the expected value is the same. It's going to be 400 people will die. And so people tend to choose the less risky program A if the problem is positively framed in terms of lives saved. Let's go back. So yeah, in this one, if we're looking at lives saved, people definitely like program A because, ooh, we love to save people, and that's the one we go for. They tend to, however, choose the riskier program B if the problem is negatively framed in terms of lives lost. And so the choices, really, remember, are identical from the perspective of utility theory, but people's preference for one or the other really depends on whether it's positively framed or negatively framed. And so down here, we can see that in program A with the positive framing, people definitely prefer the safe bet of the guaranteed saving a certain number of people. But if it's worded negatively in terms of people dying, then suddenly people prefer to gamble and choose the option where there's a small chance then that nobody will die. They want to cling to that possibility that nobody will die. The probabilities are the same numerical outcomes, but the positive wording here makes people want to choose the safe bet, where negative framing here in referring to people dying makes people much more willing to gamble in the hopes that there is a small chance that nobody will die, that they'll be able to save everybody. And so they're much more likely to go for the risky choice where there's some gambling involved. And that gets us to this field of behavioral economics, the way that cognitive, emotional, and social factors influence economic decision making. So this is clearly a branch of economics that was sort of kickstarted by people like Kahneman and Tversky, but has definitely taken off